Good morning, students. Today we are going to read distance, displacement, speed, and velocity in the topic of kinematics in the subject of physics O levels. So concentrate yourself. This is technical subject. Formulas and concepts will be used in the topic. So concentrate yourself. The first thing in the lecture is distance and displacement. And here comes the definition of the distance. Distance is the total length covered by a moving object irrespective of the direction of the motion. That is, only the magnitude is of importance. So there is no importance of the direction. Only the magnitude is important. So you have to learn this definition because this comes in the paper frequently. Now the definition of the displacement. The shortest distance between the 2 points, that is both direction and magnitude, is important. So here are the definitions of the distance and displacement. A very important question that comes frequently in the paper is an example to show non-zero distance but zero displacement. Very important question. So concentrate yourself. An object is under a circular motion. So whenever a body is moving under a circular motion, it completes one revolution and goes back to the starting point. So a body which is rotating in a circular motion, that starts from a point, complete the full orbit, complete the full circle, and comes back to the original point. So look now, displacement is zero, but distance is non-zero. So this is the example. So look now again, an example to show non-zero distance but zero displacement. An object is under a circular motion. It completes one revolution and goes back to the starting point. The distance traveled is the circumference of the circular path, but the displacement is zero because there is no shortest distance between the initial and the final point. Here comes a question that will make your concepts more clear. A car travels 5 km due east and makes a U-turn. So look now, due east covers a 5 km distance and make a U-turn to travel a further distance of 3 km. So here is the 3 km distance. Find the distance. So distance is the total distance that is covered. That is 5 plus 3, 8. So distance is 8 km. B part is its displacement. Displacement is the shortest distance between the initial and the final point. So here is the initial point, here is the final point. So 5 minus 3. So this will be 2 km is the displacement. So here is the answer. The next topic which is going to be start is the speed and velocity. And here comes the definition and formulas. Speed is the distance moved per unit time. This is the definition. It tells us how fast or slow an object is moving. So this is the function of the speed. It tells how fast or slow any body is moving. The formula for the speed is distance over time. In symbols, V is equal to S over T, where V is speed, S is distance, and T is time. So formula is V is equal to S over T. The SI unit for the speed is meter per second. So this is the standard unit. And average speed is total distance over total time. So this is the symbol of the average speed. The speed of the sound in air at room temperature is about 330 meter per second. But the fastest speed is that of the light in the vacuum, which is 3 multiplied by 10 raised to power 8 meter per second. So these both two concepts are very important as far as your paper is concerned. The speed of the sound in the room temperature is 330 meter per second, and the speed of the light in the vacuum is 3 multiplied by 10 raised to power 8 meter per second. These are important concepts regarding your MCQs paper. A question is coming now. In 1988 Seoul Olympics, Ben Johnson broke the world record to run 100 meter in 9.83 seconds. So distance is 100 meter and time is 9.83 seconds. What was his average speed? So average speed is the requirement. Here comes the formula. Distance is 100, time is 9.83. Solve it on the calculator. Here is the answer. Unit is meter per second. And other question is here. A runner completes an 800 race in 2 minutes 30 seconds after completing the first lap of 400 meter in 1 minute 10 seconds. So if first lap is 400 meter, the second lap will also be of the 800 meter because the total distance is 800, and first lap took 1 minute 10 seconds. So there is 1 minute 20 seconds for the second lap. So the requirement is find her speed for the last 400 meters. So speed will be equal to distance over time. Distance is 400 and time is 1 minute 30 seconds. But first you will convert the minutes into seconds. So 1 minute 20 seconds means 80 seconds. So 400 over 80 will give you answer 5 meter per second. Now velocity. Velocity is defined as the rate of the change of the displacement. This is the definition. The formula is displacement over time. Similarly, average velocity is total displacement over total time taken. The SI unit for velocity is meter per second. Here comes very important concept for you. An example of the constant speed but changing velocity. So concentrate now. Constant speed but changing velocity. When an object is under circular motion, the direction of the motion changes with time. So at every moment, the direction is changing. Its speed can be the same, but the displacement keeps changing because of the changing of the direction. So this is an example of the constant speed but different velocity. A body is said to move with uniform velocity if its rate of change of distance moved with time in a specified direction is constant. So this is the definition of the uniform velocity. The distance time graph. The first graph is increasing gradually. Object 1 straight line. So speed is constant. But this graph is horizontal, so speed is 0. So learn it. Okay, here comes different kinds of the graphs. Car traveling at steady speed. So look at the graph. Here is another graph. Here is more steepness of the graph. The line is straight. Here is less steepness of the graph. Line is straight. So the line rises 10 meter on the distance scale for every 1 second. So look now, we are first comparing one A and B graph. The car traveling at steady speed because line is straight. Car traveling at a higher steady speed because steepness is more. Look now. If there is a curve like this, gradually going upward, the car will accelerate. If the curve becomes of the other side, gradually downward, the car will decelerate. And here is the horizontal line, so car stopped. So learn these all kinds of the graphs. These are very important. The next is displacement time graph. Exam tip, the gradient of the displacement time graph gives you the velocity of a moving object. So whenever we have a graph, if we find the gradient of displacement time graph, we will have the velocity. Useful information about the motion of the object can be deduced if the displacement time graph is plotted. Consider a car traveling along a straight line. and with its displacement from the starting point O represented by S, what deduction can be made about the car's motion if its displacement time graph is represented by figure 1 and figure 2? So look now again, if the graph is of the form, so this is figure 1, this is a straight line graph which is going gradually upward. So look now, from figure 1, following deductions can be made. The displacement carries only positive values because it is going upward. This means that the car moves only in one direction. So this is the first deduction that is made from the graph, because graph is going upward. So the car is moving in only one direction. The displacement S increases uniformly with time since a straight line is obtained. The average velocity can be found from the gradient of the graph. So this is another deduction. The displacement increases uniformly with the time. Since a straight line is obtained, the average velocity can be obtained from the gradient of the graph. The next deduction is the average velocity is the same or constant for different time intervals. For example, so if you see, if we find the gradient at different time intervals, the velocity will be same. So it shows v1 velocity is equal to v2. I'll tell you now after finishing this point. Hence, the constant gradient of the straight line graph shows that the car is moving with constant velocity, that is exhibiting uniform motion. Note, if we consider only the magnitude of the rate of change of the displacement, that is delta S over delta t, we obtain the average speed. So look now again at the graph, figure number 1. Because this is a straight line graph, there is no curve or bend. So whenever we find the gradient at any part of the graph, the gradient will be same. So it means the body is moving with uniform velocity. Here is another kind of the graph. Look now, first straight, then going gradually up, then bending towards down at this stop, then bending down, and here is again straight line graph, horizontal graph. So look now at the figure number 2. At this point, straight line A point is there, at increasing B is there, at the maximum C is there, at the downward slope is B, D and E are there, and at the horizontal E is there. So look now, figure 2, following the deductions can be made. Since the displacement S remains positive throughout the motion, the car's position remains to the right of the starting point O, because the gradient is the displacement remains the positive because it is not coming into the negative direction. So the direction of the car will remain to the right of the starting point O. It is not coming back. So this is the first deduction, which is very important. At points A and C. So look now again, here is A and here is C. The car is stopped because these are on the stagnant position. So at points A and C, the car is standing still since its displacement S is not changing for short intervals of time around A and C. So this is the second deduction. Around B, the displacement of the car increases uniformly with time. So the car must be traveling away from the starting point O with uniform velocity. So look now, C is on the straight line. B is on the straight line. Okay, the next point is, the next deduction is after C, the displacement of the car is decreasing. That was on the downward. Now, this means that the car is traveling in the opposite direction. That is towards the starting point O. So car is coming back because after the maximum point, the displacement gradually becomes decreased. So it means the car is coming back towards the original point. The corresponding velocities will be negative. For the same interval delta t, the magnitude of the displacement change delta S1 at D is greater than delta S2 at E. Therefore, the magnitude of the average velocity at D is greater than E. So look now. At D, the velocity is greater than at E because here is the greater displacement as compared to this one. Okay, the next and final deduction is around E. The displacement decreases with time at T and decreasing rate up to F. This shows that the car slows down to halt at F. So if you look from here, car slows down to halt at F. So this was the final deduction that can be made from this graph. Okay, from the deduction from figure number 1 and 2, the following points can be noted. In a displacement time graph, the average velocity is found by the ratio delta S over delta T, where delta S is the change in the displacement and delta T is the time interval. A positive gradient of the displacement time graph indicates that the car is moving in the same direction as the displacement. A negative gradient of the displacement time graph indicates that the car is moving in the opposite direction of the displacement. A zero gradient of the displacement time graph shows that the car is stationary. So these are the deductions which can be made from the graphs. The next thing which we are going to read is the instantaneous speed and velocity. Figure shows another typical displacement time graph for an object from a starting point or reference point O. So here is a distance time graph. The average velocity of the object after traveling for 6 seconds is given by. So look now, we are going to find the instantaneous velocity of the body at time 6 seconds. So we will draw a tangent at 6. Tangent is a line that touches the curve at only that particular point. So if we are going to find the instantaneous velocity of the body at the time 6 seconds, so we will draw a line that touches the graph at only 6 seconds. So here is the tangent, and now we will find the gradient. So rise over fall, 4 over 3. The average velocity of the object after traveling 6 seconds is given by, okay, first we are going to find the average velocity, that is total distance, that is 6 meters over total time, that is 6 seconds. So 6 by 6 is 1 meter per second. The instantaneous velocity of the object at time t is given by the gradient of the tangent to the point in time. For this case, the instantaneous velocity of the object at time 6 seconds is 4 by 3. So look now again. This is the instantaneous velocity, 4 by 3. So this is the answer away from the point O. Here comes another important concept for you people is the difference between the time interval delta t used to find average velocity and instantaneous velocity is that delta t for average velocity is much larger than delta t for instantaneous. So this is the point beta. This is the difference between the average velocity and instantaneous velocity. In average velocity, delta t is greater or larger, and in instantaneous velocity, delta t is smaller. So this is the difference. Okay, here comes another question. Figure below shows the distance time graph for two trucks. Here are two trucks. One is truck A, second is B. A and B on the expedition across the Mongolian desert. So look now, the questions from this graph are, how far did truck A moves in the first hour of the journey? So truck A in the first hour? So 25 unit is kilometer, so 25 kilometer. What was its speed? Speed is distance over time, so 25 over 1, so that will be 25 kilometer per hour. That will be the speed. B part, how did the speed of the truck A change in the second hour of its journey? So this is the first hour of truck A. After that, the steepness becomes less. So look now, in this first hour of the truck is moving with higher steady speed of 50 km per hour, and in second hour of the truck is moving with lower steady speed of the 25 km per hour because the steepness gets lesser. C part is, was truck B moving faster or slower than the truck A in the first hour of its journey? So look at the graph again. Truck B is moving slower because its steepness is lesser than the steepness of A. So this is the answer of C part, slower. And the last part is, what do you think might have happened to truck A in the third hour of the journey? So look now. Here is the third hour. Here is the first, second, and third. So in the third hour, the truck A becomes stationary or halted. The truck is stopped during the third hour of its journey. Here is another question. The distance time graph shows for a motorcycle traveling along a straight road. So here is a graph. What is the motorcycle doing between point D and E? Between D and E, it is on a halt. So look now. Next question is, between which point it is accelerating? So between A and B, it is accelerating. C part is, between which 2 points is its speed steady? So B and C, its speed is steady. D is, what is this steady speed? So steady speed can be found out by putting distance in the numerator. That will be 10 to 50. So 40 is there, and here is 5 to 15, 10. So 40 over 10 will be 4 kilometer per hour. So 4 meter per second, sorry. This will be the speed. And the last part is, what is the direction traveled between A and D? So between A and D, what is the direction that is away from the initial point? What is the average speed between A and D? So between A and D, the total distance is 60 and total time is 20. So 60 over 20 will be 3 meter per second. Here is another question. If a runner takes 10 seconds to run 100-meter race, what is his average speed? So average speed will be 100 over 10. That will be 10 meter per second. Next part is there any period in his race when he runs faster or slower than his average speed? Yes, because in the beginning, the energy level will be high enough to run faster, which will be gradually decreases, and hence the speed. Next question is it possible to run round an oval running track at constant velocity? So no, because the changing direction, speed may be constant, but velocity is changing all the time. Last question is, two objects moving with the same speed may not have the same velocity. Why? What can be said about the speed of the two objects if they have the same velocity? So look now, there are two parts in the question. One is moving with same speed but not same velocity. Second is same velocity but not having same speed. So look now, two objects moving with the same speed maybe have the same velocity, because one object may be moving on straight road and other on the bend with the same speed. So the speed is same, but the velocity is not same because one is on the straight road and one is on the bending. The velocity of the object on the straight road will be uniform, but the velocity of the object on the bending will be changing continuously because of the changing direction. Next is to have the same velocity, they must have the same speed and direction. Their speed relative to each other would therefore be zero. For example, two cars are moving on a highway with the same speed, with the same velocity. So their velocity are same, but their speed is relative to each other is zero. So students, this was the topic, one of the important topics in the subject of the kinematics, that is distance, speed, displacement and velocity. Read this lecture again, learn it, make your notes. Thank you so much.